Okay, everybody, gonna try to start again. We're trying to strengthen the connection here. So I hope by now everybody has this file, and I hope by now we have been able to drop it into the Grasshopper canvas. If I don't see anything in the chat that you haven't been able to do this, then I'm going to continue forward, okay? If you still have not been able to take this CSV file and drop it onto the Grasshopper canvas, then just speak up or forever hold your. Okay, sure. Let me know when you're ready. Pretty bad. Okay, guys, so if there are any files to share from now on, I'll just send them all via email because that was not very fun, and we're now behind. I thought that just with the WebEx system, at least our partners in other locations had access to some place that they could download the files, but it seems that not everybody had that access. So, okay, so I hope that we've all been able to share these kilobyte-sized files to see what now is not going to seem that interesting after waiting for an hour, but it's going to be interesting. Okay, so post one CSV. When we drop this onto the Grasshopper canvas, Grasshopper says, I know what that is, and it reads it like this, okay? Have you guys worked with CSV files before? No? CSV stands for comma separated values, okay? It's before Excel, okay? There's also TSV, tab separated values, okay? So there's a delimiter, which is the comma, and that's how it knows when the next column is, okay? If you open it up in, if you open up the file in Excel, then you can also, and eventually it'll allow you to see that file as rows and columns. Okay? Just open this here so you can see. You can just open it in a notepad, and it looks kind of something like this. Okay, kind of a long string of information. Okay, and if you open it out eventually in Excel, if it ever does that, let's see what it's going to look like. Yeah. So Excel also already recognizes it as columns and etc. So this file, because it's such a simple file, it can be read by us by just opening it. Grasshopper also has the functionality to open the file. Now, if you're on Grasshopper 090014, you're going to get this kind of icon. If you're in a newer version of Grasshopper, you might just get something that's just one row. S, N, and C. Okay. The important thing to note, and the one thing that we're looking for, is that out of C, if we connect the panel to C, we get something like this. So we all have something like this, whether or not we have the newer version or older version of Grasshopper. Yeah, it's like this, right? Okay. So yeah, what we have here actually of the 6 sensors, actually 7 sensors, if we count the fact that the smart citizen can also have a solar panel connected to it, and the thing will tell you how much energy you're getting from the solar panel. Okay, but since we didn't have a solar panel, here's the last one. I think I'm pretty sure that's the solar panel. The value is 0. Okay, and how is this organized? Well, we have the first every other column is the sort of sensor ID, and then in between there are the values to the sensors. Now, the way that we have them set up, they're just set up as integers. So, for example, if this is temperature, the first thing, we have to divide it by 10 to get the 32.8 or 32.7. Okay, this is just to actually this is a much simpler device than our computers. So every little even decimal point is a piece of memory, and if we can avoid storing this, then we save a little bit of space. Okay, so you have to almost go to those lengths to be able to do that. You have to save all the characters you can. So that's why there's this kind of convention that Guillaume set up, so that we know more or less what the sensor is, and then we know what we need to divide it by in case we want to render that up. So let me just read his notes here. So the file itself isn't telling us what the sensor is. Guillaume wrote this little readme file here. Set it here. So the first sensor here, this one is temperature, degrees Celsius. This one is humidity. This one is carbon monoxide. Next one is carbon dioxide. Number 4 is light levels. Number 5 is number 6 is the battery, the solar panel, in case you had one connected. Okay. So we'll keep this around to remember what these are. Eventually, we could also write solve a little note in Grasshopper to understand that. So what I want to do, I just want to take these values and just for now graph them. But actually here we're going to be taking a look at the values from several different places and kind of comparing different plots of this information. Obviously, things like, interestingly enough, if we had a solar panel, we could almost substitute the solar panel also for the light levels. We would know the potential. I mean, we wouldn't have light levels, let's say in lux. We'd have more or less a light intensity. Okay, but we wouldn't have a standard international unit, an SI unit that we could use. For this, we'd need some other kind of sensor. Okay, but anyways, we'd get some kind of intensity of light actually just with the solar panel if we had it, and at the same time we'd be feeding the smart citizen. Okay, so let's start with temperature. So here at the moment, in terms of Grasshopper, what the Grasshopper sees is, you know, this could be a sentence in English, it could be a sentence in Spanish, it could be a sentence in Russian. Okay, it doesn't know that these are temperature values. It doesn't know that they are humidity values. It doesn't know to do these things to get the information in a certain format that eventually we can use it. Okay, so the first thing I want to do is I'm going to take each of my lines here and I'm going to split them with this comma. This is going to give me a new list per line, and this list is going to have all of these elements in it. Okay, so let me show you how I do that. I'm going to go here to set, and we have a whole area that deals with strings. Okay. And here we have a component called string split. Yeah, in the new Grasshopper, I think strings have been replaced by text because nobody really knew what, you know, if you're not a programmer, string doesn't make sense. But actually, this kind of stuff in programming you do all the time. You define a text, for example, this text that's coming in here. So now it's looking at this line by line, and C is the character that you want to split with. Okay. So in this case, our character that we want to split this up with in order to get the individual numbers is the comma. Okay, it's a comma separated value. So our delimiter, what's called the delimiter, is the comma. Okay. So I'm going to go to params, input, and panel. And even though it's kind of silly to just bring down a panel just to put a comma, I'm doing it just so you can see a little bit what it is that I'm doing. So I'm just actually literally putting a comma, and that's all, into this. And I'll just make it, I guess, a little bit bigger so you can see explicitly that this is a comma. The biggest comma you've ever seen. Okay, and this comma I'm going to connect to C. So before we see what kind of magical thing is going to come out of R, okay, let's review a bit what we're seeing right now on the screen, more so than the components. Can you tell me if it makes sense with the table? Okay. For example, here we have just one piece of text, no? So we have a solid table. Makes sense, right? Here we have a list of lines of text. Yeah, right. But right now, I mean, each line is a complete thing, and so we have a list of lines of text, right? When we have a list, okay. 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 Yeah. Okay. DM, our master of network systems, has created our own. Sorry, world. We're having issues here with internet. So I think it's IAAC UFO, something like this, and it's instead of, we like, apologies for this. And the cable is this kind of parallel cable. So when we come out of this split string, we get the third kind of cable. We've seen it before. We didn't confront it before because I said I was going to speak about it a little bit later. But now we have all three cables in front of our very eyes, okay? Single element, a list of elements, and a list of lists, okay? It's dark green because maybe you have gray. Yeah, some components are by default dark gray because they have nothing to show, no geometry to show. There's nothing wrong, no. Yeah, the question here was why was this component in particular dark gray, and it's because here we're just dealing with text, so there's no geometry to show, no preview to show, so that's why it's by default like this. But really the most important thing that we have to discuss here is now what we've created here is in Grasshopper what is termed a data tree, okay, which is essentially a list of lists, okay. And why do I get that? And what is this list of lists now, okay? So when I split this up, when I use this comma to split it up, I get a new list of values. Each of these numbers in each row is now turned into a new list of values. So I have a new list for my first line, and that list is going to be composed of 0, 328, 1, 398, etc., etc. So here is actually, if I open this up a bit, this is all of the information that was on my first line. Okay, it's its own list, and you see that here, this gray part, you see that it's list 0, 0, 0. Okay. Eventually, when we get to the second line, we also have its information, and that's list 0, 0, 1, and list 0, 0, 2, and so on and so forth. Okay, so this is what's called a data tree. It's more complex than a normal list because it's just a collection of lists. Okay, if you eventually were to get into programming, you'd see that this is the same as something, you know, a nested array, for example, where you have arrays of arrays. Okay, these are just lists of lists. Now, we haven't spoken about these too much, but I'm just mentioning that there once was a time when Grasshopper didn't have something like this. Everything was always a list, okay? And if you ever wanted to work in, let's say, in a kind of a two-dimensional organization of elements, like by row and column, it was crazy. And so this, although at first might seem a little strange and daunting, actually facilitates a lot of interesting structures in terms of data management, okay? Now, we saw this morning this list item component that allows us to go into the list and grab something. Now what happens when we use that same component but we operate on a tree of information, okay? So let's see this. Remember that this the first elements or every other, let's say the even elements on this list are just the sensor ID. So we're not really going to use this information. We want the odd numbered elements, which are the actually the data that's coming from the Smart Citizen kit. So this item here, 1, is temperature. I want to grab the temperature from all of the lines of that we recorded, right? So instead of having to do something kind of crazy, all I need to do is go to sets, list, and list item, the same component we used this morning, I'm going to connect from the result of my split to L, and what I want to grab now is just the temperature. So instead of 0, I'm going to put a 1 here in the index. I'm going to go to params, input, panel, and 1. Let me just make this a little stronger so you can see it a bit. Okay, so how does this component behave when now you're not giving it one list, you're giving it many lists, okay? So it's not too, I guess, too difficult to imagine. You have to kind of think of what this component is seeing. Because the component always operates on a list, it says, okay, here's a list, and it wants me to, this guy is asking me to get the first, or the index 1 from each list. Okay, great. Index 1, I have that, it's 328. Okay, I'm done. Oh, wait, I'm not done. I have another list. So, well, I might as well get index 1 from that list as well, and so on and so forth. So it looks at every list individually and grabs index 1 from that list. The result being, we put a panel there. All of the temperatures from all of the data recordings that we took here, I guess there's 38 different instances, so more or less half an hour of temperature, more or less every minute or so. So we saw this morning that list item goes into a list and grabs something. When we give it multiple lists, it'll grab that something from all of the lists. In this case, the first, the index 1 of each list, which happens to be, in this case, the temperature. Okay? Now, of course, it wasn't 328 degrees Celsius. We'd not be, wouldn't come to Barcelona for that. Like I mentioned before, in order to save a little bit of memory when we're doing the data logging, yeah, we divide it by 10, exactly. So if we want to see the degrees Celsius here, we go to maths. I mean, we haven't ever looked at division, multiplication, addition, but you could probably imagine that that's probably somewhere here in maths, and probably somewhere here in operators. We have a whole world of math, okay? So here, we just want to divide. So math, operators, division. And we're going to divide by 10. I'll just put it here in a panel so you can see it. So if you want to remember that this is temperature, remember what we did this morning. We did some grouping of elements, and we can do this by selecting a couple of components and saying Control-G, group. And I'll say here temperature in degrees Celsius. By the way, eventually, we might need to get into some special tools that deal with trees. And we saw this morning the tools that deal with lists, and we did some sorting and such. There's also specific tools to deal with tree structures. Okay? There's a lot more complexity when we start to get into this kind of list of lists, but we shouldn't be afraid of them. But it is a topic that a lot of beginners get kind of stuck on. But I think it's just a matter of applying it and trying out different things. Okay. So we have temperature. Try to extract humidity. Okay. Humidity is the next value in this text file. Remember that the even values are just the IDs of the sensor. Okay, we're not going to use this. We only want the odd values. So try to go from here, maybe copy this little block of code, and paste it and change it to the humidity. See if we can do this. That's correct. You have to actually copy the whole thing. Yeah. Just checking in with everybody else on the planet. Are you guys hearing me okay? Are there any questions out there? If you have questions, please in the chat send it to everybody instead of just privately to me. Okay, thanks, Ate. Huh? What did you put in there? Is it the second? If I look here at the thing that I split, number 0 is just the first sensor, and 3. These remember the even things are just an ID for the sensor. It's like, I don't know, something internal to the smart citizen to numerate. It's an index for the sensor, let's say. So they're kind of useless to us. We're just interested in the odd values. These are the actual values of the sensor. Yeah, exactly. No, 0 will be just the ID of the temperature sensor. Yeah. 2 is the ID of the humidity. 4 is the ID of yeah. Yeah, so there's been, so what we can do, you have to select all of the components. So you have to select them like this. Not just the square, unfortunately. You have to actually take the whole thing. So, who can guide my hands to do this? Some people have got it. Guide my hands. Copy. And paste. Okay. Move it down. Now.
A little bit up.
Okay. Here maybe? Here? We've gone backwards. We've gone backwards in progress. Okay. Put it back to 1. Okay. Amro is guiding me here. I trust in you. My right-hand man over here. Yes.
Change it to 3.
Change this one to 3. Oops.
Then change the type of this.
All right. Humidity, yes. Let's go back and let's go back to the original file here. Okay? So each of these is this instance in time that we're recording. So here, every other of these kind of digits is just an index, right? And after that, it's the value of the sensor. When we split it and we get our list, when I split this up and I get a list for each of my time signatures, I have 0, the first item, is just the ID of the temperature sensor. 1 is the value. And 2 is the ID of the humidity sensor. 3 is the value. So we're only interested in the odd elements here, which are the actual values of our sensors. The other numbers, maybe what would have been better is if we would have written what the sensor was there, but that takes too much memory in the Smart Citizen. Here we have, also a whole bunch of code for this Wi-Fi, a whole bunch of code just for the SD card. So this is like pushing all of the space that we possibly have in the Smart Citizen. So this is why DM set up this convention to give us just a very, very small ID. Even maybe we could have even saved more space by just picking it up, and just add the values. So. Humidity is in percentage, relative humidity from 0 to 100%. Okay. Good question. Let's see here. I believe we just divided by 10. Yes. Okay. Let's see what else we can extract here. So we have humidity. All right. So guys, keep extracting the data for the other metrics that we have here. And I'm just going to leave this here for a second so you see what are the division values that you need to apply to get the appropriate number, okay? Do it with everything except for the, well, up to the battery. Okay. Yeah, just to see what we get out of that. Okay, the solar panel is always going to be 0 because we didn't have to connect it. No, at the end here, Stephanie, at the end here, see this kind of /10. So each one has a specific thing you have to divide it by. Okay, so just keep that in mind.
Ruger is louder.
Yeah. Ruger, yeah. So I hope you guys are following along there in the other places. What we're doing here is we're just doing the same thing that I've done with the temperature and humidity, but just breaking this out for the rest of the types of data. Nitrogen dioxide. Yeah. No. When?
Because there are a lot of problems.
Yeah. Don't worry about it.
بعدين اقول اي شيء
Great question. So we had a question here that I think is interesting to point out to everybody as a discussion. Gabriela from Brazil asked, what is this kiloohm? You know, we have temperature in degrees Celsius, that sounds fine. Humidity and relative humidity in percentage. CO and K ohm, all right. NO2 and K ohm, okay. Light in percentage, kind of weird, but okay, I can imagine what that means. Noise in decibels, great, that's the standard unit. And battery and panel and solar panel of percentages. So actually, all of these guys, all of these sensors, and any sensor that connects to any electronic system is always changing. Well, let's say this is, maybe I don't want to generalize, but most analog sensors, what they are resistors. They resist current. They stop the flow, or they change the flow of electricity. Okay, and so what this is doing is it's changing. It's like we took numbers and converted them to colors. This takes resistance and converts it to a property that we know. So the temperature sensor resists current, and that resistance, because the people, the scientists who studied and make this sensor, understand how that resistance translates to temperature. So this temperature sensor has a specific behavior that at a certain resistance equals a certain temperature. At a certain resistance, it equals a certain humidity. And that's the same for the rest of the sensors. Okay, so the noise sensor as well. At a certain resistance, at a certain value of kiloohms, that translates into decibels. Okay, it's some of the math is really straightforward, how to go from kiloohms to the value that we think, and some of the other math is much more complicated. The sensors for CO and NO2 are those that are very complicated, that aren't calibrated yet, so we can't tell you what, usually what you'd get with these air quality sensors, these kind of gas sensors, is particles per million or particles per billion. So how many particles in a billion other particles are nitrogen dioxide? How many particles in a billion particles are carbon monoxide? Okay, that's a really complicated thing to get back, especially with these sensors, which are very, let's say, low cost. Okay, there are very expensive sensors. I mean, we're talking about in the hundreds of thousands of euros. That, yes, eventually they give us really good precision and they can give us very accurate data. Okay, but the idea with the kit is to get it in the hands of as many people as possible, and still it's still 150 euros. So it's still kind of expensive. Anyway, does that answer? And maybe a little too thorough, but all right, guys. So by now we should probably have all of our things. I'm going to catch up with you here. Let's see here. So we have 3, 5. Did I miss something? 7, 9. What should I go until? 13. Okay, so I need to update then what my tags are. Humidity, what is after humidity? Okay. There's 1,000. What a reliable guy I have next to me here. Okay. Then we have. Okay. So I'm just catching up here to all you guys here. Okay. Okay. Wow. All right. So that's the craziest Grasshopper definition I think we've had yet. Each one gets a little bit more intense. You should see some of the definitions their other tutors here have shown me in the past. I've had to decipher their process. Yes, Sophie? That's correct. Yeah, we didn't have a solar panel connected to the Smart Citizen, so it's not going to give us any reading. Yeah. This is in. We handled this morning, wrapping around the list. Remember? Okay. Okay, guys. So we have this data. What I want to do is I just want to graph it together. Okay. So I'm going to graph temperature and humidity. I'm going to use the y-axis as the value of temperature, and then along x, it'll be going through time. Okay. So eventually, what I'm going to do is I'm going to set up points for these things. The first thing I need to do, though, let's just focus on the temperature. Okay. So here, I have kind of a strange situation, okay? I have all my temperature values, but each of these is in a different list, okay? Which is weird because all I have is one element per list. But this happens from time to time when we are working with data trees and we're just extracting one element there, okay? From now on, it would be much easier to work with my temperature values if they were actually just in one list, not in a bunch of different lists that don't really relate to each other, okay? So one thing that you do sometimes when we're dealing with data trees is you want to remove all of this extra structure, all of this extra separation and indexing, and just put everything in a list like we knew before. So 0, 1, 2, 3, 4, 5. Okay, something that's a little bit more easier to play with. Okay, and to do this, we can do it several ways. We're going to do what's called flattening. Okay, we're going to flatten the list. We're going to take all of this other branch logic. A branch is one of the lists in the tree. Okay, there's a lot of different names for this kind of stuff. So what I'm going to do is I'm going to go to sets, tree, and flatten tree. It's this kind of this stump of a tree. So it's sets, tree, flatten tree. Okay. So when I flatten the tree, let's connect from our dividing value over to D. And then let's see what this gives us in the panel. So the first clue of what we've done here is the cables, right? Over here, we have something that's telling us we have information in separate lists. When we flatten that, we no longer have separate lists. We have one flat list. We just have a list. All the values are in a list. We have our indexing, incrementing on the left as we had this morning. And we can now treat it as one list of temperatures. By the way, we can also, on any of the inputs or outputs, we could right-click and say flatten instead of having this other component. Okay. On any of the inputs or outputs, if we right-click, sorry, I don't know why my Grasshopper is leaving me, but you can say flatten. So if what I'm doing, I'm right-clicking on R, and I get this little menu. If I say flatten, it'll do the same as this whole component. Yeah, I just do that so I introduce the topic to you, but then just for you to know further that in all of the inputs you have the option to do the same. We're just going to do a few of them. We're not going to do all of them. We're just going to, for now, graph temperature and humidity together. Okay, so what I'm going to do with these is here in my graph, if we think of just a line graph that we're going to do, this eventually will make up the y variable, okay? What we're missing now is an x. Okay, and x is just, points in time. I'm not going to care about the exact time that we've used. I'm just going to, for each point, I'm going to give it a different value in x, okay? Go continuously along x, all right? But I need to generate a list that has as many x values as I have temperatures, okay? So here, I know that eventually I have 38 temperature values. So I just need to create a list of numbers that has that many elements, and then I can decide how far apart they are, etc. Okay? So how do we do this? Still in sets, notice that we've been dealing a lot with things in sets. As I mentioned this morning, this is a very important area. Here in sets, we have a place called sequence. And in sequence, we have a couple of different components. that allow us to, yeah, in this case, just to generate different kinds of things. Some of them generate numbers, some of them generate random numbers, some of them allow us to eliminate certain things from the list. But right now we're just dealing with this component that's called series. Create a series of numbers. All right, sounds simple enough. And again, this component in this case is going to be gray because it's just making numbers. It's not making any sort of geometry. It's making numbers. So let's see by default what this component is giving us. I'm going to connect the panel. You see that now I'm just kind of freely connecting panels everywhere. I'm going to connect the panel so I can see what the result of this is. Remember, I haven't done anything to the component itself. I've just dropped it on the canvas, and it just by default gives me this. Okay, so let's study a bit why it gave me this. Okay, we have 3 inputs here. The first input is the first number in the series, 0, the first number in my series. Okay. The next input, the next input is the step size for each successive number. So how big is the next number going to be compared to the first one? Here, the value is 1. So we're incrementing by 1 each time, 0, 1, blah, blah, blah. And the last one you could probably guess is going to control how many I have, how many values to generate. Okay, so I start at 0. Each successive number is going to be incrementing by 1. And how many do you want? It's essentially that. All it does is generate numbers. Simple, clean, etc. So almost there. We almost have everything. This is going to eventually make up our x component to our graph. But here, you see that I only have 10 numbers. And over here, in my list of temperatures, I have 38. So I need to eventually generate the same amount of elements in here as I have for my temperatures. So in order to do this, we could say, okay, how many temperature values do I have? I have 38. So you could enter 38 here, okay? But come on, we're more clever than that. What happens if I change my file, or I have more values here, okay? So we need some kind of way to match how many elements are here and connect that over here. And well, of course, we have such an element. Here in sets list, we have a component called list length. Measures the length of a list. Okay. Sets list length. It's a little guy. Does a very simple thing. So we're going to connect here. We can connect any list, and it's going to tell us how many items I have in that list. I'm going to connect over here from D to L. Look at that. It gives us that 38 we're looking for in a way that we don't have to continuously then write it here. If we make this connection up here, now I have 38 items in my list. Remember, yes, we end at 37, but we're also including 0 in this. Okay. Questions before we continue? It's been going a little fast because we started a little late, but are we okay? I don't want to abuse you. To make a graph, to graph the temperature. Yeah. Are we okay? Any other questions? Not yet. Okay. So in our graph, we have our x now, and we have our y. So we just need to compose some points to plot these points, and then we can make a curve through these points. Okay. So first, we need to make points. We're going to go to vector, point x, y, z. You did this. Okay. Yeah, it's because, okay, so what's happening now, if you did that, is that, so you're going to create here, first a list of 33 values, then another list of 33 values, and another list of 33 values. So you're always going to be creating, if you give C a list of numbers, you're going to create a series with that many numbers over and over again. So here, let me explain it in this way. My goodness. My computer is. So if I said here, let's say I said 5, 10, 15. Imagine that we had disconnected this directly, but here I had 5, 10, and 15, okay? So if I do that, what I'm going to generate is a list of 5 elements, a list of 10 elements, and a list of 15 elements, okay? It's not reading how many elements you have in the list. It's just reading the numbers, the actual values. So we first need to say, we just need one number here. The number is how many values I have in the list, and now we create one list of 38 elements. Okay. The component, the input in C doesn't read how many elements you have in a list. It just reads numbers. So if you give it multiple numbers, it's going to generate multiple lists, with the length being the number that you input. Exactly. Exactly. It just tells you how many things you have in the list. Exactly. And again, yeah, this list could be a list of anything. It could be a list of buildings, of meshes, etc. Okay. So now that we have this connected, X is coming from here, and then Y is coming from the flattened component. This is vector point x, y, z. So if you zoom into kind of 0, 0, you should see some of the values kind of plotted onto X and Y in Rhino. No, you're looking at it in the front view. Remember, we're plotting in X and Y. So look at it in top view. That's correct. Yeah, what we're doing here is we're generating a list of points because we've inputted lists of numbers. Exactly. So yeah, these numbers, the series, is just a very basic list. Increments 1 by 1, 0, 1, 2, 3. So I wanted to plot the temperature in Y. But for X, I just wanted a continuous measure of time. So let's say x is time and y is temperature in our graph. Yeah, I could. Yeah, exactly. It would be the same in this case. Yes, I could do that. Yeah. Not in all cases though, because it's numbers. It's okay. Numbers and points, I think we'll be fine to do that. But let's say you, when we had the cones yesterday, if we would have connected a panel, it would have said cone or something like this, and we couldn't have connected that to something else that takes the surface because it would have seen the text of the cone. Yeah. And guys, to kind of complete this a bit, if you want, if we wanted to plot this as a curve, well, it's not so much more thinking to think that, okay, well, I can make a polyline out of this. If we go to curve, line, and polyline, right? And maybe turn off my points here. A little difficult to see here, but now we have the temperature plotted. To hide the points. So to hide the points, if you right-click in the center of the component and say preview, it'll turn them off. Now it's gray, showing you that it is calculating, but it's just not showing the points. So I'm going to just clean this up a bit.
Yeah, I just did it. We're gonna be.
And because we've already created the logic for the temperature, we could also just take this whole thing and should be able to just hook up the humidity . So that's another nice thing about working in this manner, is that once you prototype certain logic, you could just copy it and apply it over and over again. Okay, it's like a closed little circuit that we could just continue to copy. Estoy con 5 trocitos en como 10 minutos, 15 minutos. So guys, I want you to go through the other metrics and do the same. We'll see that obviously some of them are not in a graphable range to each other, especially the resistances from the other ones, but just try to bring them together eventually to see what we get here. Yeah. Yeah. I don't know. I wasn't there. It's a peak in humidity. I don't know. I don't know why. What was happening? You guys were taking the readings. Was there suddenly something happened? A humid.
Right? Are you over this? Right? You are not, right?
We.
No, we did.
Yes, with the kits, yes.
Yeah.
The SD cards.
Good, if you did so. Cards. You can read like.
No. Yeah, the SD cards we.
Yeah.
But Mattia, another answer to that question depending on what that value is, I'm going to look at the humidity values. Mattia asks here, why is there such a spike here in humidity? And let's see, I don't know exactly what number that is. Maybe around, I don't know, 12 or something. Let's see what we get here. So yeah, it goes up to 65% humidity. So if it would have been something like 100 in that rapid change, I would have said maybe somebody knocked the humidity sensor and something electric messed up. But because it's still within a decent range, then I'd say it's something out the humidity. Yeah. But in previous versions of this kit, there were some, let's say, more improvised electrical connections, and we saw those kinds of peaks quite a lot. You can, yes. Now that we know how to flatten. Any questions out there from the rest of the world? Sorry, I've had my microphone, my noise turned down, my sound turned down. If you have any questions, you can put them in the chat. I'm sorry? The two lines? The Y value, humidity just happens to be higher in percentage than the Celsius value of the temperature. Yeah? The X is just something we determined. The Y is what's yeah, it's going to be, but eventually we could scale these values down to something similar, to something that's between 0 and 100, and we could see, maybe, give it a try.
One of these products in the lab, I like carrying one on another, then like, can I just replace it in some way? Just to see like this diagram, like, or that diagram, and it's like.
It's hard to read. You're saying because of
how can I just replace it?
Okay, we could do a few things. We could turn others off and leave the one you want to see on, or you could, for example, give the curve a different color.
Yeah.
Yes, this is all being recorded, Oscar.
Where can we access this after it's done so we can go over it again?
1 second, please.
What was the numbers around it? Or like 32, 30,000?
Okay, I'll check it out here in a second.
But all the links and all the numbers are around it.
Okay, I'll check it out. Yeah.
I can stay on the yard there, so if you need to go, you can turn it over.
Could you please repeat the question? I couldn't hear you.
I was asking where we can access the recording once you're done, so we can go over it. We seem to have quite a few.
Once we are finished, you're going to get an email that says you're invited back into the meeting space, and this is where you're going to have the recording.
Okay, great.
Yeah, we also have 2 people here that are downloading these recordings, and eventually they're going to be starting to upload them to YouTube.
Okay, great.
They're going to do a little editing because some of these have gone a little longer, but yeah, if you want to see the raw footage, you can then, as soon as this meeting is over, you're going to get an email about the meeting space, and you can go there and you'll see the recording.
Okay, I'm going to send you one of our classes for one app. It's Grasshopper. If you wanted to maybe get the email, go over it.
I'm sorry, I can't understand you. Yes, I see the, yes. And what's this email?
This is Virgin. She's one of the one lab students, Maria. If you could send her an email as well to go over it.
Okay. Sounds good. Okay, guys, so I'm going to leave this, I'm going to save this document. Eventually, of course, these kinds of things can be made much more elaborate, and we could continue looking at the other types of metrics, but I wanted to complete one more example, which deals with ray tracing. In Rhino, we're not doing anything, no, so we don't have to show. We'll take 2 minutes here to digest the content, and when we come back, I want you guys, everybody, to have open the Rhino file that I passed you. So guys, there's a Rhino file, this GSS locations 3DM. If you could please open this file, we're going to use some of the information that's contained within it, okay? I sent it via email. It's GSS location SunPath 3DM.
Luis?
Yes.
It tells me I cannot read it since it was created by a newer version of Rhinoceros. I'm using the 4.0.
That's why we chose to work with Rhino 5 to not have this issue.
Okay.
We'll save it as a Rhino. Does anyone in your location have Rhino 5?
Yes.
Okay, so have somebody in your location with Rhino 5 open it and save it as Rhino 4.
Is it?
Do I have
Let me forward it to you.
If nobody there has Rhino 5, then I'll save it as Rhino 4 for you.
Let me do this.
Okay. And this file, what I did earlier today. Hey guys. Okay. So what I did in this file is I used a plugin for Grasshopper called Heliotrope. Okay. It's unfortunately only compatible with the newest version of Grasshopper, but really all I wanted to do is extract the sun paths at the different locations that we're doing the global summer school. So here we start to see in the different layers we have the different sun paths in Mumbai, Tehran, Istanbul, Barcelona, Lima, and New York City. Okay. So let me just look at one of them, because looking at all of them at the same time is, I hope maybe you're, yeah. Looking at them all at the same time, well, it's kind of neat, but it's hard to read. So what I did here is I got the sun path in June, in September, and in December. On June 21st, September 21st, and December 21st. Okay, and I got it from 6 in the morning till 8 in the evening. The point where the sun is exactly at that time. Okay. Now there's a few points here that go beyond that, and that's why they're like flat here. But anyways, for each location, we have 3 days in the year, and each of those days we have different hours of where the sun is at that point. Okay. So this is Mumbai, and you can kind of start to see, you know, how the sun is and how different the temperature and kind of light must be, just by the kind of orientation of the sun according to where we are. So if we look at Lima, which is in South America, we get the sun going opposite, no? And New York City, so most of us in the northern hemisphere here have this explanation, some more extreme than others, and then Lima, being down there, will have the inclination going the other way. How did I get this? Well, Brian Lockyer is a gentleman who's been developing something called heliotrope. He gave us a license to use, so all of us could actually install this on our computers. We have to also install the newer version of Grasshopper. I'm going to make this available to all of us. I don't want to consider the pain that it's going to be to move to a new version of Grasshopper in the middle of all of this, especially when all I'm doing here is just extracting the sun paths. Okay. Now, I could have extracted the sun path for every day of the year. Kind of redundant. I mean, in March, we had the same sun path as we have more or less here in September. Okay, not exactly the same position of the sun, but let's say it's so similar that for a quick analysis, and quick I mean something that takes a couple of seconds, that's enough. Okay, if we're doing an extreme analysis of the thermal behavior of the space, then you want to go on higher resolution. But for concept designs and designs, we're just trying to get an idea of what's happening with the light levels and the exposure to the light. Something like this is typically okay. Okay, just as a first glance at what's happening with light. Okay, if each location wants to use their own information, then that's fine. Let's work here with Barcelona. I'm going to work with Barcelona since that's where we are at the moment. And what I did here, I'll just show you. Actually, I have my computer at my office. I was working on it from here. And this is these components from heliotrope. So here you compose the days. So I said 2013, June, September, December. The day is the 21st, and then the list of hours. So from 6 to 8. And then for each place in the world, there's a UTC offset. Okay. Then I went into Google Earth and I looked at the latitude and longitude coordinates of each location and just recorded it here in Grasshopper into a little panel. Okay. So I combined this all into lists, and what I can do now, let me see if it'll show me. Let me turn this off here. I kind of combine all of this into different lists. So if I just here change the slider, now I'm just going through the different locations around the world. So it's a really nice, handy set of components because it just really easily allows us to access this information. These kind of solar path equations have been around for quite a long time. They're quite well studied. And they're really easy to find online and eventually, compose into a set of components. But Brian's done a really nice job of making this information available with this component set called heliotrope. And it has a series of other components. It has, for example, also some components that deal with shading and silhouettes and things like this. So it's a nice set of components. Anyhow, that's how I generated this information. I eventually baked the arcs, the points, locations, and all the text here. So the first thing I want to do is I just want to make a fake sort of plaza here, a fake set of buildings, and just try to understand how we could use this information to see the radiation on the surface of an open space, a public space. Okay. In a new layer in Rhino, and actually I'm going to lock the Barcelona layer, so I can't select anything now. So I lock the layer by clicking on this little lock over here. I'm going to create a few boxes. Here I'm using the box corner to corner height over here. And everything is actually quite small and not well dimensioned, but I think it will serve the purpose of what we want to do here. So I'm going to set that up. And then I think I have everything I need in order to do this calculation. So let's say that I have a space in between here, and I'll generate some kind of analysis mesh for that. So I'm going to go to Mesh, Polygon Mesh Primitives, and Plane. And I'll just make a default plane, 10 by 10. And I'll just draw it kind of like that. Okay, so now I just need to bring things into Grasshopper. I'm going to start a new file. And I'm going to bring in my mesh and my obstacles. Mesh. And the mesh, I'm going to go here, param, geometry, and mesh. Remember to reference things, we right click and set one, or whatever that thing is. And I'm going to bring in these other boxes as param, geometry, brec. Why not? Let's make one more. So here I said set multiple B reps. Okay, this is in param geometry B rep. Yeah, I'm now referencing the objects that I've drawn in Rhino. This one was a mesh, so that's why I used params, geometry, and mesh. And the other ones were B reps. That's why I used params, geometry, B rep. Yeah, when we're bringing things in from Rhino, yeah, we do this in params, geometry. No, the second one is B rep. Params, geometry, B rep. It's in towards the middle. 1, 2, 3, 4, 5, 6. Looks like a cylinder. What? B rep means boundary representation object. It's a polysurface. Okay, and now I want to bring in my points. My points of where the sun is at that point. Okay, so first of all, I have to make sure that I can select the points. So I'm going to unlock the Barcelona layer, and I'm going to go here to param, geometry, and point. Right click and set multiple points. Yeah, the only points that exist are going to be along those arcs, so it's not going to allow you to select anything else. Have grid snap. See down there at the bottom?
I want to set the multiple points.
In type, switch the point. See that? All the points.
Here. So I'm not sure that I connected to this one, and I can connect all together that, and then I can make one point.
Yeah, so we're missing.
But you have to shift, select all the soft skills, right click and set multiple. So that is all. And point.
Yeah, but I think we do all
the points. Yes, you have to create all.
So can you select the component and say you want to give it a name, no?
Or come here.
So select the component and hit Control P. Yeah.
All the points. Right click.
Okay, and one more question. I just made this thing, like in one layer, but I think this one should be on another one. Can you just replace this one layer?
Select this one, select this red.
Okay, let's continue on here. Since our guys have to go here in just about 13 minutes.
Okay.
We're going to use a component that is in the mesh area. The first time, we're going to use a component that is over here in the mesh area, which I think is the first time that we operate over here. There's a component, or two components actually. Down here we have one that's called exposure. Called mesh exposure for a collection of energy rays and obstruction. Okay. So what we're going to be looking at here is just direct solar radiation. Okay. We're not going to solve any indirect solar radiation, which would be the radiation that's bouncing off of every other surface around. We're just going to directly go from the sun to this little patch of space that we have over here. So this is in mesh, utility, and all the way at the bottom, exposure. And wow, we got a lot of inputs here. But we'll go one by one. And again, we saw the first day how we can go little by little and just read the inputs. So first of all is our mesh. So the mesh we already have, it's this analysis mesh, that's going to go into S. The obstacles are just going to be our obstacles that we've named here. Okay. And now what we're missing are the rays of the sun. Okay, this is classic ray tracing. Anytime you, well, maybe not anytime, if you rendered in the 90s, or in the early 2000s, you probably used a ray trace render. And actually, yeah, a lot of modern renderers are based off of classic ray tracing renders. They're just shooting light rays from different sources many times over, and yeah, to try to simulate real light. So now we have really sophisticated renders like I don't know, Maxwell render and V-Ray, things like this that do some really beautiful things. They're essentially sending, you know, many rays of light. They do it in a very optimized way. Here we're going to do it with, I don't know, how many rays, I don't even remember, sun position. We're going to do it with 30 vectors. They do it with many magnitudes, orders of magnitudes more vectors than this. So we have points. Points are not vectors. Okay? Vectors we haven't dealt with yet. This is a new type of data that we need to see how to compose. Okay? If we were just to connect the points now, it would work, but it would consider the vector to be going from 0, 0, 0 to the point. So it's like if the world was shooting light at the sun instead of the sun shooting light at us. Okay? So we need to make those vectors go from the sun to the world. Okay? Let's see how to do this. We're going to go to vector, vector, and vector 2 points. Created a vector between 2 points, kind of like making a line, let's say, but it's just something we're not going to see. It's a direction, exactly, a direction and a magnitude. So, vector, vector, 2 points. Thank you. If you put your mouse there, the first thing it tells you 30 locally defined values. Yeah? All right, guys, so we have to make vectors from the sun to the world. So if we read this component here, it's going to go from A to B. So from the sun position to the center of the world, which for now we can just consider to be the center of our Rhino model, which is this 0, 0, 0. So I'm just going to go to vector point and point x, y, z and create just a regular point. Okay. Vectors we can't see by default. Grasshopper doesn't show them to us. Okay. If you want to see them, there's a little component here in vector vector and vector display. This is just to kind of visualize them. The vector goes into V, and the starting position goes into A. We can't see them very well, but they're like arrows that point somewhere. And then I connect this vector to R. Yeah. Nice thing. Guys, there's a few other inputs here. For example, if we knew how much energy that ray actually was carrying with it, we could input that information here. Okay? Why is that? Because over here at the beginning of the day and the end of the day, because the sun is much more not incident to us compared to solar noon, the energy, the amount of energy is less, hence the light is also less. We don't have that information, so at the moment, there's other ways that we could get that information, but at the moment we don't have it. Okay, so we're going to consider that the light is even. So these are things that we need to remember when we're doing these kinds of analysis. If we wanted it to be even more precise, we'd have to feed it the energy that each ray has. And this eventually can be found, but for now we don't have it. Okay, so now what do we get? Out of E, we get the exposure. And what am I actually calculating? Because I'm analyzing this mesh, what I'm actually calculating is if the light from the sun is hitting these vertices. At some points, it might be obstructed by these buildings, so it doesn't actually reach there. So for each of my points, I now have a different value. Okay, for each of my vertices of my mesh, I have a different value for exposure, which is coming from E. Okay, at some point here, there's 15 rays that actually hit it. At another point, there are 13 rays that hit it. At some other point, there are 21 rays that hit it. So because of my obstacles, this is not being exposed in a similar way. Each point has its own particular exposure that now we can see. Remember when we gave colors this morning to the points? We're going to do the same thing now, except we're going to do it to a mesh, and the information is coming from the sun. Okay? But it's the same kind of concept. Now we have the information already gathered. All that's left to do is take that information and apply it to our geometry. Okay, so the hard part is over. The part of coloring the geometry we already did this one. We just have to see how to do it. Remember our old friend Parent's input gradient? So I know that eventually I have to give the gradient all of the values of exposure. So that I know is coming out of E, and that's going to go into T. Now L0 and L1 aren't going to be 0 and 1. We have to make them so that they are the same. They encompass what's coming out of E. We could do it in the same way we did it this morning, but we actually are at a different level now. We're more experienced, we're more intelligent, we are more agile in Grasshopper, so we're going to go to a next level. Okay? Out of R comes our exposure range. Okay, so it's already giving us the information of what's the minimum exposure and what's the maximum exposure. Okay, so I just need to take these two values and make sure they come out of two outputs instead of just one that we have here. Okay, so this being a domain, I have to decompose the domain. I'm going to go to math, domain, and domain components, decompose a numeric domain. It's like deconstructing in the other kinds of things that we've done. I'm going to connect from R to I. And now we have these two numbers out of two separate outputs. I'm going to connect S to L0 and E to L1. We have one component left, just one. You might think that now we're going to use the custom preview component that we used this morning, but we're going to take a slightly different approach. Because meshes are a different animal altogether, each of the vertices can take on a different color. What can I help you guys with? Okay, we'll go back to this. It's just that you guys need to leave at 6, and Vicente is going to be waiting, and I'm kind of rushing this part, but we're going to go back over this. Don't worry about it. I have it all recorded. So I have to do one more thing here. I'm going to go to Mesh, Primitive, and Mesh Colors. Mesh, Primitive, Mesh Colors. I'm connecting my mesh to the M and the colors to C. Unfortunately, we have this kind of backwards. What should be least exposed is colored in the way that is inverse, because we put the minimum 9 into L0, which is corresponding to these warmer colors. So all we need to do now is just rewire so that S goes into L1 and E goes into L0. Here, I increase the resolution of my mesh, and I can see a little bit better all of the exposure actually happening. How's it going over here? We have something? Okay. Yeah. Yeah. Cool. In this case, no. I mean, I actually increased the resolution of my mesh, so it's now 100 by 100, so we can really see very well how that exposure, we can literally see the rays of the sun at different times coming through there. What's nice about meshes that I didn't speak about before about other objects is that when we bake them, you can bake the color. Actually, I hope it doesn't crash with me here. Yeah, so you can bake the color and render it. With other objects like surfaces and points and curves, you can't directly just bake the color. You have to kind of take a, you have to do something else. Yes? Yeah, you might get something weird. What you're probably seeing is the fact that you have your original mesh in Rhino and the new analysis mesh as well. So you should select that and hide it in Rhino. So select the object and type hide and press enter. Okay, so another thing you could do is you select the analysis mesh here and preview off. Atreya is asking me how I increase the resolution of the mesh. Well, Atreya, the good way, the appropriate way to do this was if I would have made the mesh in Grasshopper, that would have been really easy. I could have just used the slider to increase the resolution of the mesh. Here in Rhino, what I did was I went to Mesh, Polygon Mesh Primitives, and I made a new mesh plane. But here, I'm changing the number of X faces and the number of Y faces to be more. Here I did 100 by 100, and then I just drew the mesh in the same area. So I kind of cheated a bit. Okay? But then I took that new mesh and I referenced it for my analysis mesh. But really, that would have been much simpler to do in Grasshopper, which with this mesh plane that takes width and a height. We could do some sliders to just more dynamically see the thing. But anyway, crash. Yeah, be careful with increasing the resolution because just like an image, you're still increasing the exactly. So my friends, I apologize that I've done this in such a crazy way. I think it's been a little fast, but we sort of lost an hour with the just sharing some very simple files, unfortunately. So I'll make sure to do that much earlier before so that we don't have these issues again. Eventually, we have our very talented folks back here preparing for you a little 3D model of your plaza with the buildings and all of this. So we're going to apply something similar to our plazas to understand how this works with real geometry and how it's actually working in the real city of Barcelona. And with this model, we'll also also do some of the information, we'll cross-reference that with some of the information from the Smart Citizen to get to kind of complete the analysis with the videos and the pictures that you took yesterday, okay? So again, I didn't mention this, maybe I mentioned it, but yeah, the plaza that you're going to be analyzing is the first plaza that you looked at yesterday, okay? And tomorrow, we have all day to work on this, okay? We've sort of had a crazy time here trying to fit everything in. But tomorrow we'll have a day to just kind of work on this, put things together, and start to get some ideas of what's happening on our plazas. Yes. Yeah. So it's gonna be low key. Yes. So guys, I hate to rush you because I already rushed you. But Vicente is going to be waiting for us at 6:30 in Lesseps. Okay? He's a patient guy, so it's okay. But he is the architect of the city, so we shouldn't keep him waiting too long. But he's very excited. I think he told me he's going to bring maps and drawings and things like this. So he's got something up his sleeve for you guys. You're going to be accompanied by tutors again. We're all going to go together. And yeah, he didn't want to tell me what he was going to do with you, but I think you're in good hands. So we're done with this guy here. I'm going to send off the Barcelona participants to meet Vicente Goyart. I'll stick around here. If there are any questions from the other locations, I apologize. This was really kind of rushed because we lost this first hour, and I had to get these guys off to Vicente. So if there's any questions, anything you want me to go over, what I'll do is I'll now save these Grasshopper files and send them off to everybody so we have some references. And what I would encourage you guys to do in the other locations is to apply this and apply this on your other sites. So in Mumbai, I don't know if you have some 3D models of the area that you guys are working on, but it would be interesting to see from all the locations around the world how this kind of exposure is working. And in New York as well, if you want to play with, I don't know if your site is the Brooklyn Navy Yards themselves or if you're going to be working somewhere else, that would be interesting to see. Istanbul, if this is relevant to the network study, then this could also be nice. Again, this is a very sort of cheap tool. You know, it's not going to be as expensive, let's say, as another level, something like Ecotech, and it's not going to be, you know, expensive as something like Radiant. But the difference is that we did this in a few, you know, we put this together and the analysis, if we change it, takes just a few seconds.